Hey guys, welcome back to the channel. I have another interesting video. This time working on a 5.7 liter MEFI 4. This is sent to me Lance Hunter from Florida. He said his fuel pump driver not working, no fiber reference to crank and cam sensors, injector not receiving the signal from the drivers, 12 volts present at all injectors, no spark from coil, no signal from ignition module. Yep, this is actually what I can see here as well. So let me move you over to the display first. All right, so, and let me take this. Well, actually, and there is not a problem. So, all right, so let's try to attempt test. I have right now, as you see, the multimeter connected to the fiber reference and sensor ground, and we got nothing. So there is no fiber reference in there. Let's try to talk to this computer. I have the Rinda connector and everything powered up. Hopefully you can see behind me that my simulator is on, which I'm going to try. To turn it off and turn it back on for the video so he can see and you guys also as well. But yeah, so we got no communication, no power up. All right, so let me turn this off. So right now I got just power up for the simulator, but nothing going into the computer itself. So main power, ignition, no fuel pump relay. That's what I'm touching in there. Should have light up, and we should have seen 5 volts in there. So the computer is 100% dead. So the other thing that I want to do, because I'm using the sensor ground for the reading, let me unplug that, and you see now that that did have an effect on the signal. So, but remember, look at the right part in the meter, and it shows millivolts. So that is almost nothing in there, right? So I'm connecting it still to the fiber reference. I'm just moving my lead because I was using the harness connector that I have. I'm going to connect it to a ground point in here in my simulator to see if we are missing the ground or the fiber reference. Okay, so well, let me just read 1 second because it says 5.9, but that is 5.9 millivolts. So I'm going to keep the ground in there, and I'm going to move my now positive lead to a 12 volts, so actually to a 5 volts, because I can have all that in here. All right, so you see when I have 5 volts, now the meter shows 5 volts, not millivolts. So we do not have the 5 volts. It's not that we're missing the ground in the computer. It's actually that we don't have a fiber reference. So I'm going to plug it back in because you see it says 5, but it's 5 millivolts. So there is nothing in here. The computer is not, it's not able to wake up on anything because obviously we got nothing in there. All right, so let me pause the video and I'm going to open the computer. Well, before I do that, let me actually show you what we have here. So that is Lance paperwork. So you can see it in there as well. And then I think you might be able even to read it. I'm going to read the, oops, give me 1 second, guys. The last digits on the computer. So I always start with the letter 8. It says 8715-80025. And it's a MEFI 4. The part number on the computer is 125-84052, which is those can change depends on the settings that are built for Volvo Penta, Cruiser, or so on. But yeah, so we got no communication. We can definitely reproduce his concern. So let me open the module and I'll be right back. All right, guys, I want to mention that the computer was actually pre-opened. So that is a little concerning. I can definitely see wires pushed to positions that shouldn't be there. So let me get my microscope in here. I'm going to first get myself look into this. So let me put you into here like that. You're, no matter what, it's going to be very hard for you guys to even see anything in there. All right, let me see what I see first before I plug this back into there. Because yeah, I can see jumper wires all pushed up. Oh my God. Yeah, this is okay. Yeah. Oh wow. Yeah, somebody was poking in here. Not so bad on the right side. So My connector J2, yeah, definitely somebody was there pulling pins. I don't see any shorting. So I'm going to get my tweezer just to duplicate, well, not duplicate, to corroborate that all those pins that whomever was poking in here didn't pull apart, because that will explain the no communication. Although I don't see any broken jumpers, but these are very fragile. So I'm not sure who was here or why. Because I always believe that, if you open a module, it's because you will repair it. Because otherwise, I don't understand what was this in here open for. Or, again, I need to know all this before you send the modules. Like that, I just don't connect the module and possibly burn my simulator because there is a major short, even though mines are protected with, a protection. But I want to make sure, I'm not, creating a bigger damage into a board just because somebody was here. And on the other side, I can definitely see the same problems with the, it's very common sometimes in these modules that the clear gel that they put in here, it looks like they didn't let it dry properly, and they put the modules kind of like sideways, and all the liquid went to one side, and then dry it up. And that at the end, through years, it will end up breaking the jumpers, and I have seen that many times. And but yeah, I don't know why somebody was here. If first of all, the side that they were poking is not the common side that breaks. I'm just going on to this side where the gel has been pushed to make sure the jumpers are still attached. I'm sorry guys, I'm not showing that in here, but I mean I can move you over to the other camera if you want to see what I'm doing. But microphone, microscope, everything is on the way, and it's very clear. I mean, very too much light for you guys to see something. The camera is adjusting a little bit so I can see that it's happening. So yeah, all I'm doing is with a special tweezer that I have for this, I am touching every single jumper without bending it. I don't bend them. So I'm not sure why that was so damaged on the other side, which is the easiest side. Yeah. So far, nothing is broken. Because if I have broken wires, well, then I need to correct that first. No broken wires yet. Usually are right here in the center, the ones that I see the most common to break, and I have never repaired this side because of a broken jumpers. I have repaired like 20 of those. Yes, somebody was here because these green jumpers all pushed to the side. But yeah, so nothing in there. Let me look around a little more on the module now that it's like this, because I need to see if there's any other damage, an obvious damage that might have been created by whoever was here. Again, I'm just looking around. I don't see nothing damaged. Wires are not broken. Definitely fingerprints all over in the gel of whomever was here. But yeah, no, I don't see nothing in there. So power is off. I'm going to reconnect this. Yeah, this is J1. And this is the connector for J2. All right, so I'm going to put this here. Not sure if I'm going to be able to show that. But yeah, so I'm going to move you over to the display capture. And on the display, I'm going to, let me put you 1 second, guys, in here to get the data that I need to perform the test. I'm gonna need that positive. I still connected to ground on my multimeter. We're gonna check the powers and grounds going into everywhere. So I'm going to power up the computer, which I have done. And now I need my folder, what I have all the data for these computers. For those that are watching the video, all the information you see here is my Salazar Diagnostics proprietary. I have done all these myself. This is not nobody else's. So yeah, all the information that you see here is you can use, but you cannot disperse or sell. This is my information. All right, so let me move this back to my screen because I was using it in another video into the other screen. Here. All right, everything is ready. All right, so guys, you will be seeing in the right side, on the left side, partial of that information. So what I'm going to move the mouse. Hopefully you can see. So I'm going to move in between the two images, and you can see that red arrow right, kind of like in the center higher part of the screen. It's a red arrow. That's the pointer of my mouse, and I will be touching. Let's check this area first. So yes, I am in the same way. So let's check for these 13 volts and look at the response on the meter. We have the 13 volts in there, which we have a 6.3 here, and we don't. And so we don't have the 6.3 in there. Got 1.7 volts. The other one should be 12 volts. We got the 12 volts. So I am now on the second tantalum down. Again, I'm moving the arrow. Hopefully you can see again. So we're missing that 6.3 volts. Let's go down into the next one. For this, I'm going to have to link down in here. Oops, out of focus. Need to adjust my camera. Okay, now I can see. All right, so let's see if we have those 5 volts in here or not. We got 2.2 volts. 2.2 volts. So yeah, definitely we're missing rails. So let's check this other 13 volts in here. And now I am zoom a little bit, and now it's a white hand. Not sure why it does that when I'm poking around in here, but all right, so let's see. Yeah, we got 13 volts. Very important side is that BGT transistor right here. We should have 12 volts on each of those legs. Let's see if we have that. All right, 12.5 and 12.5. So yeah, it's looking more like the regulator, the 5-volt regulator right here. That this might be the problem. Before I go and jump into that, let's check the 5-volt reference and the 3.3 volts right here on the microprocessor. Yeah, you guys can see that. So I'm going to check the 5-volt reference first. Trying to move the microscope to get to there, so I poke the correct place. Yeah, we got no 5 volts in there. I'm touching in there. I'm going to move into the 3.3, but I doubt that we have either one. Yeah, we don't have nothing in there. All right, so we got nothing. The next place that I want to check is this voltage regulator right here to see if we are getting 8 point something volts in there. Hard to keep everything accessible for me with so many things in the way. I'm trying again to get you as much as possible view of what I'm doing. All right, so I'm going to touch the upper section, which is the same as this in the center. Should have 8 volts in there. We got nothing. We got 1 millivolt. All right, so I'm touching the center pin. We got the same 1 millivolt. Let's look at the right side. We got the 12 volts in there, but I doubt that I have 11 volts. Well, I do have the 11 volts. Well, if that doesn't have the 8 volts, the tantalum on the bottom should not have that 8 volts. And most probably what is happening is because the next part of this circuit is that little BGT this transistor right here. Again, I'm looking at the 8.1 big one, center of the screen, where the computer board is. That next to it, that should have 5 volts into one side, 4.4, right? And I have it marking there. And I know for sure that we will not have that. So we got nothing in that side. And we got nothing on the other side. So yeah, this is definitely looking like that. Oops. Let me go back in here. Okay. Like the voltage regulator. One place that I want to check is these 12.5 volts in here, right next to this 40,000 kilo ohm resistor. Because if we're missing that voltage, the regulator will not operate. So let's see if we have that. And we do. All right, so following that line next to it, and all those are covered. Let's see what we have after that resistor. Let's see, because you have 5 volts in here. I don't feel and see nothing. We're getting 3 volts. That should be 5 volts. So that is one place. So we should have in here 5 volts, and we got, like I said, 3.3. So what I'm right now is through this resistor, we should go in this pad, and this should be 5.3 volts. That also supplies voltage to this regulator. So what I'm going to do first, just as a test, because we only got 3 volts in there, I'm going to get myself just 1 second. Okay, I got the jumper wire that I'm going to use, and what I do is I'm going to plug it into my simulator on the 5 volts through a test light. That's very important, because I'm not just supplying, any amperage. I'm not sure, I have not really measured what amperage might be there. I just want to poke in there with the 5 volt reference and see if the computer reacts. No reaction whatsoever. So that means that is not the problem. We're not missing, we are missing that feed, but that is not changing anything. I'm going to switch the ignition off. Just make sure I am in the correct place. The problem is a little hard to do with the distance that I need to reach, and trying to keep you guys posted. All right, so I'm there. I'm just switch. Lost it again. Let's see if I can just touch in here. Yep. And no change. And I'm only drawing 70 milliamps on the computer. So yeah, that is definitely, we have a completely dead computer. Let's keep poking onto that voltages around the 5 volt reference. So let's now check these two, right? Those are outputs. And we know that I'm missing, I know that I'm missing those because, yeah, we got minus. That means there's nothing in there. Let's check the other one. We got 6 millivolts. So yeah, this is a completely dead regulator. And let's check these 12 volts right here on the right side, just to make sure that we're not missing a main power feed. Make sure I'm the correct side. I think I don't get nothing in there. So we are missing that power feed. And we're missing the 6.3 volts, which is we have a 3.3 here, which is doing nothing. And then the next one up right corner should be 6.3 volts. And we got nothing. We got 1.7 volts. Next to that, we should have a 5 volt reference. We got 1.3 volts. Then we should have a 3.3 in the center. We only have 30 millivolts, or 0.3 of a volt. 300 millivolts, sorry. And then the same thing on the big one, which, if the one doesn't have, the other one doesn't have either. This should be a 5 volts. I'm just going around to follow. I'm going counterclockwise Now doing the test, and I don't see anything. Let me check in here. We do have that 13.1 right next to that 5 volts. Nothing in here. Nothing in there. All right, so let me provide that 12 volts that we're missing in there with the same wire, the same jumper through a test slide onto that cap that we're missing in here. I'm just going to focus a little better because I cannot see. And that should be the first cap after the big one. No difference on amperage, and that will tell me immediately if anything is changing. The reason I do this, because I can see the amperage. If the amperage goes high or too high, I know that we have a short. I don't see a short. So this is sounding more and more as a, a bad 5-volt regulator. All right, guys. This is as much as I want to show on the video for this preliminary test. I'm going to remove that epoxy they put around this regulator, and then see if any of these pads is broken. I have repaired multiple computers this way, and we'll see. But sometimes it's just not that. Sometimes it's a short or a bad passage of, because this is a multi-layer circuit board, printed board, and sometimes it's impossible to repair, but we'll see. All right, so I don't want to hold you too much, Lance. This is just to show you that I'm indeed in the process of testing your computers and give you a result if it is a repair or not. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye-bye.